The output floor assessment commands were originally devised to enable contractors laying concrete floors to comply with the concrete specifications for the contract. It can be used for other tasks as well, but I'm going to relate these tutorials to pre-strike floor levels and how we can measure their deviation from design. So we're comparing the as-built to a specification. I'm going to begin by looking at the floor assessment deviations options. But I'll start by showing you the help documentation, which contains a few useful diagrams. There are three measures within the deviations command, one of which is to define a design level, and that design level can be a datum value, or indeed it can be an existing survey, because that design level doesn't have to be constant across the entire floor. It can slope, it can have undulations. The contract will specify the maximum deviation above and the maximum deviation below the design level, and these are parameters which we will enter in the command. LSS will then calculate which of the surveyed observations lie out with that specification. Secondly, we can use a straight edge to define the deviation from a slope between 2 points. And the third measure is a measure of the smoothness or roughness of the concrete surface. We now create a new survey into which the results are going to be placed. This is the design level, 36.87, and if you just look at the surveyed points, you will notice that most of them do deviate from that value, but many of them don't deviate by very much. We type in our design level, and as I've already explained, we can use a survey as an alternative to a datum value, and we now enter our contract specifications for the maximum allowable deviation above and below that design level. We will calculate the deviations for the entire current survey, select OK, and it has previewed those points which lie outside of that specification. But we'll go through the process and create the new survey. At this point, it's important to recognize that in the survey's test data there is a floor assessment prototype which contains unique feature codes which will be useful in the floor analysis commands. It lists all of the points, and if they lie outside of the specification, then they will be recorded with a PDEV point feature, and they will display their absolute differences between the design level and the surveyed level. Create a new survey. Floor level again is the same. This time distance maximum deviation, so we set our design parameters for the straight edge calculation and the length of the straight edge. This time, because it's going to lay a virtual straight edge over each surveyed observation and slide it along from end to end, it then rotates the straight edge and repeats the exercise. So it's going to look a little bit like pick up sticks when we've finished, and we can set the angular interval for that laying of the straight edge, so the 22.5 degrees is about right. We can now preview again those straight edges where the deviation in level exceeds that 50mm specification. If we query the links, they are coded DDEV, which stands for deviation exceeded. We'll see that each of the lines is 6 meters long, and we've got a level difference of 18mm, and because the contract specification said 15mm, that is therefore the reason why this has appeared as a out of specification section of the floor. There we have 19 millimeters. This time we're trying to determine whether the surface itself is planar or rough. Again, we have a maximum deviation from a smooth surface and a length of straight edge, and this is going to produce a similar result to the distance deviation, but bear in mind that this is measuring dips in the concrete surface, therefore has picked up different deviations. In these areas the roughness of the concrete surface is beyond the contract specification, and if we query the links, the code is DSTE, which means the straight edge values have been exceeded.